Assalamualaikum and hi to the panelists and to our viewer. Welcome to my presentation of MEC 601 Final Year Project 1 with the title of Performance Analysis of Water Cool Chiller at Engineering Complex. This video is presented by me, Syafiq Tham bin Iskandar Nasruddin Tham, and my supervisor for this project is Puan Rosnadiah Binti Bahsan, and my co-supervisor for this project is IR Haji Anuar bin Hashim. In this video, there are 9 content of my project. Let's enjoy this video. For the project summary, district cooling system with thermal energy storage (TES) has been replaced with water cool chiller system in engineering complex at UiTM Shah Alam to study on the operation and analyze the performance of new water cool chiller system at engineering complex by using the energy and exergy analysis. The raw data will be collected using building automation system during normal operation time for daily and monthly. An Excel spreadsheet will be developed to analyze the data for each component. The result will be comparing with previous chiller performance and test data from manufacturer. The result will be tabulated and might be useful for facility department, UiTM, to monitor and analyze the chiller performance in the future. Next, for the project background. Malaysia is located in Southeast Asia. It is known to have tropical weather which average temperature is 32 degrees Celsius, where air conditioning within a building is important. Therefore, the need of comfort environment is very crucial. Chiller can be divided by 2 types, which are water cool chiller (WCC) and air cool chiller (ACC). Both water cool chiller and air cool chiller has common components, which are condenser, evaporator, compressor, and expansion device. However, the difference between both is air cool chiller using normal ambient air, while water cool chiller using cooling tower as a humid air stream. To achieve energy efficiency, both chiller and cooling load should be analyzed in the building, and analysis should be executed to obtain a knowledge of the plant. A periodic chiller plant data analysis will assist us to gain a better understanding and track performance, aiming to update and change the management rule and introduce more effective up or down sequencing strategies. This is why, when selecting a chiller, the efficiency and coefficient of performance (COP) in rated operation or partial load are the important element. This is the schematic diagram of water cool chiller at engineering complex. For literature review, this part I have 4 parts in literature review. The first is Introduction to Water Cool Chiller. Chiller is described as an overall package that includes a water chiller, the condenser, compressor, and chiller are integrated into a single unit with internal piping and controls. Water cool chiller has common components which are condenser, evaporator, compressor, and expansion device. Water cool chiller remove heat by using pump that send water through seal condenser and disperse the water through cooling tower. Water cool chiller is more efficient than air cool chiller because it is using water evaporation for cooling use. Next, for the analysis of chiller performance. The efficiency of water chiller is rated by coefficient of performance or COP at peak design condition. When COP is higher, the more efficient of the machine. The coefficient of performance water cool chiller is presented as relationship with the cooling water temperature and chiller load factor. Coefficient of performance is defined by ratio of heat removed from water by the evaporator divided by compressor mechanical work. An excellent full load COP value is said to be over 5.0. Actual COP classification is shown in figure. Next is ideal vapor compression refrigeration cycle. This is the schematic and TS diagram for ideal vapor compression refrigeration cycle. The ideal vapor compression refrigeration cycle that consists of reverse Carnot cycle can be eliminated by vaporizing the refrigerant completely before it is compressed. At state 1, refrigerants enter the compressor as saturated vapor and compress isentropically to the condenser pressure. State 2, refrigerant enters condenser as superheated vapor and as a result of heat rejection to surrounding, it leaves as saturated liquid at state 3. Then, the state 3 is throttled to evaporator at state 4 as a low-quality mixture and completely evaporates by absorbing heat from refrigerated space, completing the cycle. The last is exergy analysis. The second thermodynamic law states of energy quality that the entropy of a reversible system remains constant for any sequence to occur in an open or closed system. Lectures claim that without the application of external work, the transfer of heat from a hot object to a cold object would never occur. Next content is the problem statement. Problem statement is divided by 4. Replacement of thermal energy storage system to water-cooled chiller system. Previous chiller was placed underground and this is difficult to do maintenance. Leakage of ice cell storage made the thermal energy storage cooling performance drop. Water-cooled chiller has longer lifespan since it can be maintained easily. For the objective, the first objective is to analyze the energy and exergy efficiency of the water-cooled chiller system using first law and second law of thermodynamics. Next, energy and exergy analysis of water-cooled chiller at engineering complex and compare with the test data from carrier which is manufacturer. The last is to investigate the effects of various operating conditions on the performance of the water-cooled chiller system performance. Scope of work. The analysis will be covered weekly sets of the actual data from the water-cooled chiller system during semester break and regular semester. The study will be more focused on the critical parts that contribute to the highest exergy loss on the system. An Excel program will be developed to investigate the effect of various operating conditions such as steam inlet temperature, chill water inlet temperature, load factor on the water-cooled chiller system. Next is the limitation of project. Students were not allowed to enter UiTM due to movement control order due to COVID-19. The operation data cannot be collected manually due to prohibition entry UiTM. If the pandemic getting worse, all the chillers cannot be testing and running at full capacity. The data for full load cannot be obtained and might be affected the performance result. For the methodology, here is my flowchart of methodology. After finding the title, I go to the problem identification and do the preliminary study, and then visit and pre-data collection at chiller plant engineering complex, but it postponed due to COVID-19. Next is the collect actual data and Excel spreadsheet preparation, calculation and data analysis, observe and compare the result with discussion, report writing, and end. For the preliminary study, in engineering complex at UiTM Shah Alam, there are 4 chillers of water-cooled chiller type for 8 buildings, which are Block 1 to Block 5, Tower 1, Tower 2, and Podium. Each chiller consists of 900 ton capacity and using refrigerant 134A. For the schematic diagram of water-cooled chiller, cool water from chiller will be supplied to chiller water pump, which is CHWP, and will be pumped to air handling unit and to heat exchanger. After that, go to the building. Hot air that return from the building will back to the chiller and go to the condenser pump CDP to elevate the water to the cooling tower. Cooling tower will reduce the temperature before return to the chiller. Here is the simple schematic diagram for the process. Chiller to the building and the hot air will be back to the chiller and go to the cooling tower. Cooling tower will reduce the temperature and enter the chiller. Visit and collected data at chiller plant. The water-cooled chiller has been installed at engineering complex and the manufacturer specification is shown in table below. The data related to the performance will be recorded in building automation system and will be analyzed in the Excel spreadsheet. Brand of the chiller we are using in the engineering complex is Carrier. The refrigerant used is refrigerant 134A. Refrigerant weight tonnage is 1,192 kilo. This is the collect actual data for weekly period. The parameter needed at chiller plant will be collected and it will be compared with the provided data from manufacturer, which is Carrier, and the previous chiller system, which is district cooling system. The data will be evaluated according to Air Conditioning, Heating and Refrigeration Institute AHRI standard. Table below shows the sample of raw data collection from the chiller plant. To calculate the data, we need coefficient of performance, efficiency, and load factor will be calculated by using this formula. Expected result. At the end of this project, the actual performance of the chiller plant will be determined as a guidance for future improvement. Test data from manufacturer will be compared with the normal operation reading. And this is the reference. That's all from me. Thank you for watching. If you have any question, don't hesitate to put in the comment below. Thank you.